Hello, my name is Hannes Rycker, and I would like to give a brief background for this video which we are wishing to show to you. Someone once said, I don't know who, but I think it was a wise motto: a problem is a brilliant hidden possibility. I think that is very true indeed. And what I always found in my touring of the air gas industry during the most recent 30 years was that the problem for one very often also was a problem for some more. And if this was the case, then of course one should try one's very best to try to solve it. So my life has consisted for many years now in trying to find some solutions, very basic one often, to make some sketches, to create some models, and then leading up to having drawings made and then prototypes built by specialized manufacturers. This has been an interesting phase, and today life has become so much more easier in transferring these ideas. I mean, we have, as you see here, the internet, we have the YouTube, we have the email, we have the Skype. The whole story is that we can now discuss and develop and exchange views in a very, very smooth way, and we can do that on a global basis. So our wish with this little video is to make and give you an overview of the already 25 years of independent cryogenics and the ideas which we have been working with and which we also have realized. Some more ideas are in the pipeline, more of that later on.
Well, imagine a small cryogenic tank which is possible to both transport and to use as a cold converter. The heritage was very much the liquid cylinders, which were tall, rather small diameter standing and not so easy to handle. This is a 600-liter tank which you can use with forklift. You can lift it, you can move it around, and you can use it as a cold converter, 23 bar working pressure. But what is essential here is that this tank is a separate tank with everything on board, including a small pressure blow coil, standing on a rubber suspension on a stainless steel pallet and protected by a stainless steel framework. This means, of course, that if something would happen to the frame or to the pallet due to rough handling, it could easily be swapped or exchanged in your local depot. And the heart of the matter, the tank is still intact. That's the key story with the cryogenic IBC. Imagine that your company is finding a new potential customer, and nobody really knows will this application with air gases be a good one or not? How much is going to be used per day or per week? Is it going to be a commercial viable thing? This Cryo site is intended to be able to bring a mobile cold converter onto site in a very easy way, to park it, to fill it up, and then of course to be able to check how much is being consumed for this new application per hour, per day, or whatever. So you see an 18 bar tank, decent sized, with the possibility to put in load cells between tank legs and the skid which is there to protect it and make it easy to park. So this is a rather convenient way of trying out a new application, Cryo site. Imagine a flexible tank system which could be used overnight on rail and daytime on road. That was the background for the CryoFlex development. 20-foot bottom framework with grappler pockets and with the possibility to have different sized tanks onto that frame. All in stainless, very nicely made, and the intention, of course, that every tank size up to a certain limitation would be possible. You have a very complete filling and discharge arrangement, you have a fully interchangeable pump system, you have flow meters. so that different chassis could use different tanks. The combination possibilities would be great. We have had some different projects where this has suited very nicely in. You of course need to have a possibility to think in a logical, logistical way to create this kind of system and make them very, very flexible and useful. And one could also imagine, of course, that the logical further development was to integrate the leg system into the CryoFlex bottom framework, meaning that if needed, the tanks could be parked at customer sites, just pull out the legs, exit the air of the chassis, and you will have a possibility to park the tank at the customers or in your own depots. This was a very suitable further development and made life even more flexible. Imagine back in the 1980s when almost all cryogenic liquids were moved by road, semi-trailers, or by rail cars. Both systems quite accepted, but of course there was a general development in containers of different sizes coming along for different cargoes. And the scene here is then the 20-foot cryogenic cryotainer, which was then a fully stainless steel design with filling discharge arrangement with interchangeable pump system with flow meters as option. And of course this made it possible very much in the beginning to move LAR, liquid argon, not only over long distances but also over intercontinental distance. We had a system with pre- and recooling, making it possible to cool down the argon and also then increase the transport possibilities. So this was the beginning of a long development with intermodal cryogenic tanks. Not only 20-foot ISOs on swan neck trailers with dedicated operations were then able to get on the market, but also what we call the swap body, the 20-foot framework but increased tank volume. And that of course made it possible to move liquid to the 20-foot cost, but with bigger, 25% bigger volumes. Very logical development, and we saw a number of companies going in this direction. Perhaps negative side, the center of gravity fairly high, as you can see. Also that quite a lot of metal is of course moved around in the chassis and also in the framework. Very many companies in Europe mainly, but also in other markets, choose the intermodal cryogenic way. The swap body, the extended swap body to 30,000 liters, different working pressures up to 22 bar. Everything was quite possible, and the interchangeable pump on or not on board was a very, very flexible solution indeed. And it was possible to imagine also different sizes. Quite logical was of course to go from 20 foot up to 30 foot. You see here a 30-foot container made for liquid nitrogen mainly, but also for other specialty gases like liquid ethylene, and then the bigger sizes also for LNG. So it was a very logical development. You can see that the fill and discharge always in the same area, the pump systems always in the same area, space enough for the flow measuring equipment as well, of course. It was also possible to imagine very big ones. What you see here is a 40-foot cryogenic container, and again in the rear part you see the full filling and discharge pump and flow metering within the 20-foot measurement, but the overall length is here 40 foot. This of course used in special cases for liquid nitrogen moving overnight on rail and daytime on road, getting a very flexible and modern distribution system going. Today one can say this size has been now a standard size for LNG, and one can see a very fast growth in that area indeed. And imagine that on all these tanks, from basically 10,000 liters cryoflex via 20-footer swap bodies, 30-footers, 40-footers, there is the possibility to use a fully interchangeable pump system. The pump here consisting of a CryoStar or a Cefco pump with an electrical motor and a control box. And seen here is the very easy disconnection with a U-bent pipe between the filling lines, and for using the forklift, and it was quite possible within a good half an hour to swap the complete system in and out. You might need it with a pump, you might go long distance without pump, you might need to serve the pump, and so on and so forth. A rather flexible, nice little Colombi egg. Imagine if one could move cold converters in the very same easy way as the cryogenic containers, namely in 20, 30 or 40 foot modules. Wouldn't that be nice? That was very much the idea behind the cryo-cold system, which was made very strictly in accordance with the measurements of 20, 30, 40 foots, but then of course being transported empty, erected, put onto a cross-bottom beam, and then used as a cold converter with thermosiphon and so on and so forth. This was then a very interesting idea, we thought, and I can only confirm that many other people thought it was also quite useful to have a very complete tank, TÜV approved, going out easy and being lifted with one crane and so forth. Unfortunately, it became slightly costly, and we all know that cold converters must be seen as a commodity with a very strict euro per liter ratio. So imagine next step in our life, back to the drawing table, making a very good flow schematic, very streamlined, 4 legs in the bottom, but back to a tank which was more cost effective, but to be shipped over the world on a flatbed container resting on wooden cradles and strapped down into a 20, 30 or 40 foot flatbed container. All possible, of course. Question is whether or not the upper corner castings were so very expensive that one should disregard it or not. It's a question of philosophy. The shark trailer was a rather novel concept, and the whole intention was to create a very modular trailer system, whereby the tank, including the cabinet, were one unit, being able to park that on legs. Underneath you had the possibility to add one out of 4 different specifications for the bogie within hours, and in the rear you could exchange the complete pump system within some few hours as well. And that meant, of course, that like a modern airplane, this unit could be put into operation to a very high degree. Anything going into service to be swapped within some few hours and then back on the road. The intention was there. It was made in about, I think, 15 units. I think people were rather satisfied with everything except the tire weight. It became a little bit too heavy due to many things being added onto, not only from a design point of view but from an approval point of view and so on, and therefore the competitive product in weight was not really given. Since my very early days in cryogenics, 30 years back, the center of gravity was also regarded as a key story. There are thousands of cylindrical cigars, we call it, around on the market, trailers which has a fairly high center of gravity. Therefore, the ambition with the Cryo design was to very much get down with the center of gravity. In addition to that, to create a very low tire weight to increase the payload, and also to make the overall length, track and trailer, shorter to make the easy access better. I think this picture from a liquid argon trailer en route in Austria, I think shows quite a lot of what we are all after. You see the low center of gravity. You don't see the low tire weight, but I can assure you with the aluminum tank, the aluminum cabinet, the aluminum framework underneath, the tire weights are low and the payloads are high. And that has resulted in a rather intensive activity, building cryogos of different sizes in different executions, with aluminum inner, stainless inner, with aluminum outer all the time, and therefore creating different options to make it as light as possible. Right now more than 150 are on the roads in Europe, more is on the way, and I'm glad to confirm that the basic piping arrangement in the rear, which we made in a model 1-to-1 to start with, has been very much confirmed to be an easy, ergonomic, almost intuitive tank piping design, and works very smoothly, cools down the pump quickly, gets the liquid out through the flow measuring system, and the operator has everything in eye height under control. This has proven to be the right way to go, high spec, but very, very well working. Intention, as with the containers, has been also to create a rental possibility via partners, and in this case a Dutch company, the Schenk Tank Transport, has been investing in a fleet of cryogos which are available for rental or with a combination of rental and operations. A lot of effort has also gone into creating a even easier access to customers, and you can see on this trailer on the low picture, the Strombeck one, the last axle has an opti-turn function. It goes slightly up, reducing the turning circle quite a lot. Very often the first axle is then a lift axle, so you have all the possibilities that you can think of. In addition, the cryogo has been built as fixed tanks which are then used on chassis which are having 3 or nowadays very often 4 axles. On this picture you see a tank which has the possibility also to connect the electrical pump to a generator on board the chassis, which is of course making it fully autonomous. You can also choose, of course, very often people do choose the hydraulic pump systems, no problem. The 4-axle version, which is nowadays very often chosen, is making access even easier, and tank sizes then of course slightly larger also. During the last 12 years with the cryogo development, we have been doing our best to increase both performance and the knowledge available. So we have a website, we have made a life cycle cost software, we have made a passport showing the filling and operative aspects, we have made a booklet describing the overall story, we have made a payload to tire value instruction, and we have also created a USB video showing the whole story from plate to pump test of trailer manufacturer. So this has been done by the team you see below, the cryogo team in Salzburg in Austria, and the best thing of course is to come and see for yourself what it is all about.
Well, perhaps just some few words about ourselves. The I you see here is of course standing for independent, and the intention from day one was to be able to discuss in an open way with all who are interested within the gas industry for new ideas, how these could be solved and how they could be organized in a better way. So independent was from the very beginning a very key statement. Well, the C, of course, standing for cryogenics. And with cryogenics, we here talk about liquid nitrogen, liquid oxygen, liquid argon, linloxlar, but to a certain degree also LNG. So, we are closing the circle with this black field, which we think symbolizes looking forward, I see. And the ideas which we have done so far, you have seen on this video. It's always easier to look backwards, of course, where we can show you the ideas and what they look like in reality. The more interesting thing is, of course, to look forwards. What could be done more to make the moving and storing of air gases in liquid form even easier, smoother and safer. So this is what we are up to, and we are of course very keen to listen to your thoughts, and we are most welcome to contact us on our email address, our Skype address, or in any other suitable form. Welcome.